Good morning, dear students. Today, let us discuss the transportation problem and how to solve the transportation problem. So first, let us consider the mathematical formulation of the transportation problem. So let us see first the transportation table. So there are m sources. Say this is source 1, source 2, and so on. Source m. There are m sources. Then the number of destination is n. So destination, so D1, destination 2, destination 3, and so on, destination n. The number of units produced from source 1, so this is denoted by say A1. From source 2, the amount of production is A2, and from source m, AM. Then requirement for the destination 1 is denoted by B1, destination 2 is B2, destination 3 is B3, and so on, destination n is Bn. So these are the requirement, and this A1, A2, AM are the supply. Then cost of transportation from source 1 to destination 1 is denoted by C11, similarly C12, C13, C1n. This is the transportation cost from source 2. It is denoted by C21, C22, C23, C2n. Then from source m, it is denoted by CM1, CM2, CM3, CMN. These are the transportation costs. Then the amount of quantity to be transported from source 1 to destination 1 is denoted by say X11, X12, X13, X1n. These are the amount of quantity to be transported. From source 2, it is denoted by X21, X22, X23, X2n. Similarly, from source m is denoted by SM1, SM2, XM3, XMN. This is the structure of the transportation table. So now X11 plus X12 plus X13 plus on X1n should be equal to A1. This is the amount of to be transported from source 1 to different destination. So sum of these quantities should be equal to A1. This is summation X1j, j goes from 1 to n. This is equal to A1. This is for first row, then second row, and third row, then mth row. By combining summation Xij, j goes from 1 to n equal to Ai, I equal to 1, 2, 3 up to m. This is for summation in row wise. Similarly, we can define for column wise. Column wise is we can denote it summation Xij, I goes from 1 to m, equal to Bj, J equal to 1, 2, 3 up to N. So this is the total demand, then this is the total supply. For the balanced transportation problem, this should be equal. So summation Xij equal to summation Xij, J goes from 1 to N, I goes from 1 to M. So total supply should be equal to total demand. This is the first condition. Then total transportation cost is C11, X11, C12, X12, and so on. Lastly, CMN, XMN. So this is equal to double summation Cij, Xij, I goes from 1 to M, J goes from 1 to N. This is the total transportation cost. So our main objective is to minimize the transportation cost. So our objective is to determine the number of units to be transported from different sources to different destination, so that the total transportation cost is minimum. So the mathematical model is to find Xij. In order to minimize Z, this is denoted by Z. So we have to minimize Z equal to double summation Cij, Xij, I goes from 1 to M, J goes from 1 to M. This is objective function subject to summation J goes from 1 to N, Xij equal to Ai. This is the total supply. Then summation I goes from 1 to M, Xij equal to Bj. This is the total demand. Xij is greater than or equal to 0. The system will be balanced if total supply is equal to total demand. This is the mathematical model for a transportation problem. So now let us see one problem. First we have to construct the model. So a dairy farm has 3 plants located through a state. Daily milk production at its plant is as follows. Plant 1 produces 6 million liters of milk. Plant 2 produces 1 million liters. Plant 3 produces 10 million liters. Each day, the farm must fulfill the needs of its 4 distribution centers. Minimum requirement at its center is as follows. Distribution center 1 require 7 million liters. Distribution center 2 require 5 million liters. Distribution center 3 require 3 million liters. Distribution center 4 require 2 million liters. So let us form transportation table by using this information. Transportation table. So there are 3 sources and 4 destination. So plan 1, plan 2, plan 3. Then distribution center 1, distribution center 2, distribution center 3, distribution center 4. So plan 1 produces 6 million liters and plan 2 produces 1 million liters. Plan 3 produces 10 million liters. And distribution center 1 require 7 million liter. Distribution 2 5, distribution 3 require 3 million liters, distribution center 4 require 2 million liters. This is the daily demand. So total supply is 17 million liters, total demand is 12, 15, 17. So total supply is 17 million liters, total demand is 17 million liters. So this is the balanced transportation problem. Then transportation cost from plant 1 to distribution center is 2 is in terms of hundreds of rupees, so these 2 should be written here. Then next is 3, these are the transportation cost in terms of hundreds of rupees. This is 11, next is 7, then 1, this is 0, the next is 6, next is 1, then this is 5, then 8, this is 15, next is 9. So these are the transportation costs. So now methods for finding initial basic feasible solution. There are different methods. For some of them are northwest corner rule, next least cost method, then Vogels approximation method. There are some methods for finding initial basic feasible solution. So first one, let us discuss about the northwest corner rule. In the northwest corner rule, the assignment is done in the following way. So first, the northwest is this cell, this is the northwest. First we have to start here. So total supply is 6, demand is 7, so we have to write here 6, then remaining is 1, this is exhausted. So now first row is over, then next consider the remaining cell of the table. Next, the northwest corner is here, so we have to assign here. Here is 1, here is 1, so we can assign 1. So now first row exhausted, second row exhausted, only third row, first column also exhausted, northwest corner is here, we have to assign here 5, this is 10, so we will take 5, then this is remaining is 5. So next we have to fill up here, so we have to take minimum 1, 3 and a 5, we have to take 3, then remaining is 2, this is exhausted, then last 2, we have to write 2 here. So this is the allocation made by northwest corner rule. So now you calculate transportation cost. So 2 into 6 plus 1 into 1 plus 8 into 5 plus 15 into 3 plus 9 into 2. So this is 12, this is 1, this is 40, this is 45, this is 18. So this is 13, 14, 16, carry 1, 5, 9, 10, this is 11. 5, 9, 10, 11, yes. This is the transportation cost. This is the one of the method for finding initial solution. So the solution is total transportation cost is 116 when x11 is 6, x21 1, x32 5, x33 3, x34 2. This is the basic feasible solution. So this method is known as northwest corner rule. Then next, let us see the second method, least cost method. So I will start again. Next, the least cost method. So first you have to check all the transformation cost of the table as a whole. So first you select the minimum one. So the minimum is here. So 0 is the minimum. So first you start allocation here. So here is 1, here is 5. So you take 1 here. So you remove this. The remaining is 4. This is the first method. Then next, you take the next smallest one. So 1, 1. So we have to do here, but there is no entry in the second row. So we'll have to leave this place. Then next, the smallest, 2 is here. So we have to allocate here. This is 7, this is 6. You put 6 here. So remaining is 1. This is exhausted. Then next is 3. But there is no entry in the first row. So we have to leave this. Next, the smallest is 5. So 5. So here is 1, here is 10. So you allocate 1. So this remove. So the remaining is 9. Next, the minimum next to 5 is 7. But there is no entry. Next, 8. Here is 4, here is 9. So you take 4. So this finish. Then remaining is 5. So the next minimum cost is 9. So here is 5, here is 2. So you take 2, 3. Then the last one we have to put here 3. Finish. So now you calculate transportation cost. 2 into 6, 0 into 1, 5 into 1, 8 into 4, plus 15 into 3, 9 into 2. So this is 12, this is 0, 5, 32, 45, 18. So this is 13, 15, 20, 22, carry 2, 5, 8, 9, 112. 7, 9, 14, 22. Yes. This is 5, 8, 9. Yes. Transportation cost is 112. The solution is Z equal to 112 when x11 is 6, x22 1, x31 is 1, x32 4, x33 3, plus x34 2. So this is the initial basic solution of the given problem. So this solution is given by least cost method. This solution is not an optimal solution. We have to verify the optimal solution. So this solution is given by least cost method. The previous one is given by northwest corner rule. So these are the just initial solution. For the final solution, we have to check the validity of the optimality solution. If this is not optimal, then we have to go further iteration and try to improve the optimal solution. So the third one, Vogels approximation method, is another method for finding initial basic feasible solution of the given problem. So today let us stop here, and the next class I will take up Vogels approximation method for finding the initial basic feasible solution. After that, we will apply optimality theory by using Modi method, and sometimes we call it UB method. So by using that method, we can check the optimality condition. If this is not optimal, then we have to take further iteration. It will go on until final optimal solution is obtained. So this is the method for finding initial solution. So thank you.